What's up everybody, welcome back. So in this video we're gonna work on a procedural recoil. Since we already have most of the system set up for the ADS, that shouldn't be too much work. So let's get into this right away. First of all, we need to add some stuff to our animation blueprint. So I'm gonna open the animation blueprint and start in our event graph. And we need to add custom events. So let's add a custom event and I'm gonna call this fire weapon. And we need another custom event, and that's going to be stop fire weapon. And we need a few variables in here as well, so let's add one. And the first one is going to be a boolean called apply recoil. So that should be a boolean. And we need a few transforms in here, so add another one. The first one is going to be called recoil, and that should be a transform, so set it to a transform. And let's duplicate this one, and I'm going to call this total recoil. And we need a third transform, and that's empty transform. So we need a 0 transform in here, so let's save it so we have it ready to go. So for the stop fire weapon event, I'm going to drag in my apply recoil and set it to false. And that's all we need to do in here. The fire weapon event needs an input, so let's add a new input. That should be a transform, so that's fine. And I'm going to call this recoil transform. That's not the best naming probably, but it's going to have to do for now. So our recoil transform, that's the amount of recoil we add with each shot. And we want to add it to our current recoil position. So I'm going to drag in my recoil, I'm going to drag off here, and I'm going to compose a transform. And we can add these two together. So for now, I'm not going to make this too complicated, and I'm simply going to drag in my total recoil. So that's the target position we want to achieve. And I'm going to save that. And after that, I'm going to apply the recoil. So make sure we set apply recoil true. And for now, we are done in here. So I'm going to compile and save this. And first, I'm going to go to my first person character. And I'm going to create a fire weapon event in here. So we need to get our animation instance. So we can call those events. So first, let's get our anim instance. And we want to get it from our first person arms. So get the first person arms mesh, anim instance. We need to cast this. So cast to first person animation blueprint, because that's the blueprint we are using. And let's store this as a variable. So that's our anim instance. And we have that ready to go. So let's create an event to fire our weapon. I'm going to use the left mouse button. I'm not going to bother creating an input now, so just say left mouse button. Besides the anim instance, we also need a boolean, so create a new variable, and let's call this fire button pressed. Let's drag it into our new event. If we press the button, we're going to set it to true. And if we release it, we're going to set it back to false. So after that, we want to call our fire weapon event in the animation instance. So drag it in and call fire weapon. So we need a little bit of room here later, so we might as well create it right away. So let's add a line trace in here so we can see what's actually happening and where we are aiming. So I'm going to add a line trace by channel. And for the starting point, I'm going to use my aim socket. So that's the socket we added at the beginning of this series. So you could also add your muzzle socket, for example. But since we are using our aim socket as the aiming point, I'm going to use that. So let me see. We have our rifle over here, and we added the socket which we use to line up our ADS. And I'm going to add this one for the line trace. So let's see, we need to get the weapon mesh in here and get the socket location. We want to get it from our aim socket. and plug that into the starting point. After that, we also need to get a socket rotation, and again we need it from our aim socket, so make sure you plug that in. From the rotation we can get the forward vector, and we can multiply that so we can bump it forward. So multiply by int. So let's say something about 100,000 should do. And we're going to add these vectors together. So get your starting vector and add a new vector to it and plug that into the end location. For the draw debug type, make sure you set it to for duration so we can see what's happening. And after this, we only need to add a little delay. So that's pretty much the fire time of your weapon. So since this is an assault rifle, let's say something about 0.1, 10 rounds a second. That sounds decent. And after the delay, we want to call our animation instance again and call the stop fire weapon. Make sure we connect it up. And then all we need to do is check if we still have our fire button pressed or not. And if we do, we're gonna loop back to the beginning, so to the fire weapon in your anim instance. Let's clean this up a little bit. That should do. So we have this set up, and all we need to do is add some values in our recoil transform. So that's the actual recoil of the weapon. So let's split the struct pin over here. And I'm going to split it again. So we have a bunch of floats to play around with. That's maybe not the most clean solution. Let me recombine these. And I'm going to recombine them again. And I'm going to drag over here and say make transform. And then I'm going to split them over here. I don't know why, it just looks a little bit cleaner to me. Doesn't really matter, whatever you prefer. So for the location Y, that's going to be the forward and backward movement of the gun. For the location Z is down and up. And then we have the roll, which points it like upwards. The pitch is going to tilt it left to right, and we have the rotation yaw, and that's going to actually point it left to right. The location X is moving it left to right, so that's probably the one you use least, but obviously you can play around with these values. So first I'm going to simply use the Z location so we can see what's happening, and I'm going to say random float in range. And I want to move it upwards, so that's negative, I think. So let's say maximum of -1 maybe. So that's the minimum. So let's say -4 as a minimum and a maximum of -1, something like that. I'm gonna leave all of these to 0 for now, just so we can have a better look of what's happening. So compile and save this, and we need to go back to the animation blueprint to actually apply the recoil. So if we go to the event blueprint update animation, and I'm going to continue from that, I'm going to drag it down so it looks a bit cleaner. And let's add a branch in here, and we want to check if we are applying recoil or not. So drag in your apply recoil, and again I'm going to clean this up real fast. Go. So from the apply recoil boolean, we want to interp our transform. So we're going to add a transform to our ADS bone. So we need to determine how much it's going to move, and we're going to use the interp node so it has a nice smooth movement, and that's going to do it all for us. So right click and look for interp. And we need to interpolate transform, so look for T interp to. We want to interp from our current transform recoil to our target recoil, so that's the total recoil. I maybe should have called it target recoil, I don't know. So for the delta time, you want to plug in the delta time from the event itself. And for the interp speed, that's how fast it's actually going to move towards the target. So you could play around with this and have it vary for each weapon. So for now I'm going to simply set it to 15 maybe, and that should work fine. Now we need to store this into our recoil again, so we know where we are at this point. And after that we want to check if we are maybe back at the 0 position or not. So if we are already centered in the screen after we applied the recoil, or do we need to apply recoil back to the center of the screen. So I'm going to add a branch in here. So this first part is actually moving the gun up, kicking it up, and after we're going to pull it down again towards the center of the screen. So we're going to check if our current recoil is close to 0. So simply do equal to, and we're going to use the nearly equal. Now we can't leave this pin open, so we're going to drag in our empty transform, so that's the 0. And we could change the tolerance a little bit, otherwise it's going to take a very long time to actually reach the 0 again. So let's say 0.005, that should work. And for the rotation you could do the same, 0.005. We're not actually messing around with the scale, so that shouldn't be an issue. Make sure you plug this into the condition of your branch. And then we need to interpolate back to 0, so we're going to use the same node again. And we want to interp from our current recoil to 0, so that's the empty transform. So plug that in here. Again, we need the delta time, so we can get it from here. And I'd like to set this a little bit lower, so the centering goes a bit slower than actually kicking up the gun, but obviously what you prefer, play around with this and set it up the way you like. So we need to save this in the recoil again, and make sure you plug it into the false pin, connect these up. And then for the first branch we also need to link the false pin straight into the second branch. So if we are not applying recoil, let's check if we are back at the center of the screen, and if not, we're gonna pull the gun back down again. So that's what happens here. And now all we need to do is plug this value into our ADS bone. So let's go to the animation graph, and we're gonna copy the transform modify bone node again. So create a little bit of room over here. And copy the previous one, link it up. Now make sure you have the translation and rotation mode set to add to existing, and it's in component space, so that's fine. And let's drag in our recoil over here and split it, and we can plug in the translation and the rotation. And that should work. So let's compile and save this. Now you could see for all of these previous nodes we have our fast path enabled, and for this one we don't have, because we're splitting the transform in the anim graph. So if we would happen to split this in our event graph and save just the location and rotation over here, then we could make sure the fast path is enabled on this node as well. But since we're moving around the recoil transform quite a bit, it gets messy, so it's not really hard to do, but for the sake of keeping this tutorial clean, I'm not gonna do it, but if you would like to, you could. So compile and save this, and let's see how this looks. So that's kind of working, but it keeps firing, although I already have the button released. So let's see, what did we screw up over here? Probably in the first person character, I didn't set it back to false. So fire button pressed, back to false, and now I should be able to stop firing. So let's see. That's better. So we have a trace to show where we are going, and we have the trace going straight through the aim socket, so that's nice. And the recoil is kind of working as well. It's moving the gun down instead of up, so that's not what we wanted, but for the major part it's working. So let's close this down and go back to the first person blueprint. So this should be positive values to move the gun up. So minimum 1, maximum 4. Now let's see, it should move the gun up instead of down. There we go. As you can see, it applies the recoil nicely as we wanted. So let's make it move around a bit more. So I'm going to add the Y location, which is back and forward. So in this case we do need minus. Minus is moving it back. So let's say minimum of -3 and the maximum of -1. And for the roll rotation I'm gonna apply, well, something like that should do as well, I guess. So pitch, it kind of depends on if you like how it looks, but I kind of like a little bit of pitch in my animations. So let's say -3 to 3 adds a bit more variation. And for the rotation, you don't want to move it left to right too much probably, but again, for a LMG you probably want bigger values than for a handgun, so mess around with this. And obviously you could store values in a data table and make sure it's different for every weapon. So let's say -2 to something we can see that's working. So we have most of this set up. I'm not going to move the gun left to right. So let's see. So that's definitely a bit more recoil. So it's raising the gun, and we have rotation as well. So we have left to right variance, but it still stays kind of grouped to a maximum of where we put it. So that pretty much works. So now we have an animation that's making the gun rise a lot. Obviously that doesn't look too great, so we probably want to lower this value. So say something about 0.5 to 1. So it doesn't raise the gun too much, and we're gonna angle it up a little bit more maybe. So let's say -4 to -2 for the roll rotation. And let's see. So that's a bit better already. Now it angles the gun up more instead of just raising it. So as you can see, you can play around with those values and adjust the recoil to what you prefer. In ADS it's also working. So we have a pretty decent system here. And we could fine tune it if we would like. So in the animation blueprint for the alpha, you could bump this down in ADS. So your animation isn't as intrusive and you have smoother recoil in ADS. So you could mess around with that. And obviously in the event graph, you could also mess with your interp speed. So if you want to the recoil to climb faster, you could increase this, or if you wanted to center faster, you could increase this, and you could mess with those values. And what I'd like to do in here as well is disconnect these and split them so we can clamp them. So for the location vector, you could probably just clamp the entire vector. Clamp vector size max, and you could say something like 8 units maximum, and plug that into the location. And if we split the rotators, we could simply clamp the floats. So as you could see, without clamping, it already has a pretty good maximum because of the interpolation speeds. But if you want a bit better control of the values and the maximums, you could clamp them in here and make sure it doesn't exceed values. So let's say the roll is upward angle. So if I don't want the gun to point up too much, I'm gonna say a maximum roll of -2 maybe. So minimum 0, maximum -2. For the pitch, well, you don't want a lot of pitch either, I think. So -3 to 3, otherwise you're gonna get a really big spread left to right. Oh, that's pitch, sorry. So that's actually tilting the gun. That's not affecting our aim too much. So we could use the yaw as -3 to 3. So that's left to right. And for tilting the weapon, you don't want too high values because that pretty much looks a bit weird, but having a little bit of tilt in there is kind of nice, I think. So let's say -2 to 2, something like this. So now it's not going to exceed those values, and we have a more controllable recoil. See, that should work. And as you can see, it stays much more grouped now. And it's pretty much only moving left to right. So I probably messed up a value, something. 0 to -, I might have switched some of these around. But you get the idea. Clamping floats in here. Make sure you have a nice maximum to your recoil. And increasing the values in your first person character obviously also makes it climb faster. So there's a lot of things you can adjust to make it fit your weapon. So thanks for watching, everybody. I hope this clears up a little bit and you could start adding your recoil and improve the system. Thanks for watching, guys. Talk to you later.